Hi everyone, I'm Loganathan from Loga QA Automation channel. Welcome back to the next video in our Python for Testers series. In this video, we will cover the important topic in Python, which is OOP, right? Object-Oriented Programming. And in the first video, we will cover the fundamentals. So first we'll try to understand the concept of OOP, and then we'll understand the different components like class, constructor, access operator and methods, and also we'll understand how the memory management will happen when we create a class and when we create objects. To start with, what is OOP? OOP is nothing but it is just the replication of real world grouping, right? So I'll give you an example. Say you are a designer of a mobile phone, and the next month you need to produce say some 10,000 units of mobile phones. So what will you do as a designer? You will sit and create a blueprint, right, in your computer or maybe in a chart, whatever it is. So you create a blueprint, and that in that blueprint you will give the dimensions and you will tell how the look and feel should be of your mobile, what should be the length, what should be the height, what should be the breadth, and then what should be the quality of your display, what should be the quality of your camera. All those things you will define. So those are called attributes of the mobile, and also you will define the functionalities of your mobile, right? So for example, when a particular button is pressed, it should call the particular number, and when you are typing something and clicking on a button, it should send that typed message to another person. And or if you want to store a contact, you can type the name and then put the number, and then you can store the contact. So all these are functionalities of your mobile. So first what you do, you're creating a blueprint, right? You're creating a model of your mobile. Once it is completely created, what you're going to do is you're going to take a copy of this for 10,000 times, and you're going to create 10,000 mobiles. So that is what is OOP concepts all about, right? So first we are going to create a class, which is nothing but a blueprint, and then we will create copy of those classes, instance of those classes, which is nothing but object here. So those are the real mobiles which we produce. Okay, with that metaphorical example that I've given, what I'm going to do is I'll straight away jump into PyCharm, and I'll start with a first Python file. So I'll name it as test01. And how can we create a class? So for creating a class, we need to use the keyword called class, and then we need to give the identifier, the class name. So I'll give it as mobile as the class name. All right, and then put a semicolon, and then for now I don't write anything inside the class, so I'll simply put pass. So what I do now, class is created. Let me try to print this class, and let's see what is happening. Okay, you see that it says class and then it says mobile. This is my class name, correct? Good. When it comes to naming convention, okay, for example, all the inbuilt classes like say integer, for example, a is equal to 10, and when I try to print the type of a, you would see that it says class and then it says int. And then if I try to mimic the same here with a string, it says class string. All the inbuilt classes will start with a lowercase letter, so it is better to use camel casing when it comes to user defined classes. So I'll go with class mobile. So if I have another word mobile class, then I'll put it as mobile and then class. So let me run this. And as you see that it says mobile class. This is my user defined class. I have not covered what is __ main yet. I will cover it in the later point of our video series, but please wait until I come to that point. But right now you understand the inbuilt classes are named with lowercase letter at the beginning, and 99% of the percentage of the time the user defined classes will go with capital letters at the beginning, and we'll follow the camel casing. Okay, this is good. So next what I'm going to do is, let me print the type of this mobile class. So what it says, class is the type. You remember, so a is equal to 10, and if I print type of a, it is going to give me class int. But now when I say this, this says class type. Okay, right. Next is print id of mobile. So mobile case, what is it going to do? It is going to give me the address of this class where exactly the class is stored. All right. So now we have the mobile class created, and now I'm going to create a copy of this mobile class. How can I create a copy of this mobile class? We need to create an object. Object is nothing but a simple variable, so I'll give it as mobile object. So obj mobile is equal to mobile class, and then just a open brackets, close brackets, and we say mobile class of. The moment we say mobile class of, we have created an object. So let me see, print obj mobile. So what it says, main mobile class object at this particular location. So this time it says it's an object. What object it is? Mobile class object. So that's why it says mobile class object, right? So far clear, right? So now let me add. So what I'm going to do is, I'm going to add a few attributes. Say obj mobile dot say length is equal to 10. Obj mobile dot say breadth or width, let me say width is equal to 20, and I am printing the length and breadth, length and width. Let me run this. So it prints 10 and 20. You clear? So what I have done, I have created a class. After creating a class, I am creating an object for it. How can I create an object? Nothing, just a variable name is equal to the class name with the square brackets. So it creates the object, and using the object, what I am doing, I am defining the variables, object variables, I can say for now. Let me come to the point when I'm explaining about class variables, object variables and all, so that you will get better understanding. But for now you understand that I'm creating some variables inside the object, and I'm giving values to it, and I'm printing those variables. Okay, are you clear until this? Good. So now let's see how we can put these variables inside our class. Okay, when we are creating the class itself, how can we do it? So that's what we are going to see next. And before that, I want you to understand the memory allocations, right? So what is going to happen in terms of memory when we create a class, when we create a variable and all, right? So for that, I'll go back to the slide and explain you. So here it is. So the moment when we run any Python program, what will happen is, it will first create the Python virtual machine, which is nothing but PVM. Inside the Python virtual machine, we'll have three different memories. One is stack memory, another one is heap memory, and then one is class area. Okay, so when the class is getting created, say mobile class, first it will get created at class area. Okay, so let me go here, Control Q, and then, okay, scribe is what I have to type. So this is where the class is getting created. What is the class? Mobile class. So I put it as MC, and MC is created. Inside MC, you will have all the code that I have written. For now, I have written only pass. Okay, remember it like that. Then when I'm creating an object obj mobile, so this I name it as OM. So let me put the OM will get created in stack memory. The moment it creates the OM, and it's going to have an address, correct? So here the OM will have an address. Immediately this gets copied into heap memory because I'm creating an object. Okay, so a copy of MC is created. When a copy of MC is created, this is called your object memory. Okay, this is called your object because it's an object, and here a memory will be given. Say for example, this is 1, 2, 3, and this 1, 2, 3 will get stored here. 1, 2, 3. Okay, now what I'm going to do is, here when I say OM dot, that is obj mobile dot length, so the variable gets created here, right? So OM dot len is equal to 10, OM dot breadth is equal to, or width is equal to 20. You get it? So class area is stored, class area will store the class whatever I have written, and then heap memory will be used for creating the copy of the class, and then all the objects that I am creating will be put into heap memory, and all the instance variable or object variables I am creating will be created inside the object memory. So this entire block is called object memory, inside which it is getting created, and then a new address will be added, and that address will be given back to stack memory. So hereafter, when I'm saying OM dot len, if I'm printing OM dot len, what it does, it goes to 123 dot len. So 123 dot len is 10, 123 dot breadth is 20. For example, if I create another object, instead of saying obj mobile, I'm saying this time obj tab is equal to, again I'm calling the same mobile class, and then I go with, this time length will be more, right, because it is a tablet. So 30, and then with little bit increasing 40, and then I'm going to print obj tab length and obj tab width. So see this 30, 40 is printed. What is happening here? Here one more copy of this MC is created, and this will have an address, say 4, 5, 6, and here what will happen, instead of OM it will be OT dot len, OT dot len is equal to 30, and OT dot breadth is equal to, or width is equal to 40, and this 456 will be returned here. 456 is stored, and then here we'll have OT. Okay, this is OT is the object, and OT object will be pointing to the address 456. This 456 will have a memory in heap, that is object memory. Inside the object memory we are storing the object variables ot.len and ot.width 30 and 40. So next time I'm calling this 456 dot, that is ot dot len, it will return 30, ot dot width, it will return 40. Clear? So that is what has happened here. Good. Now I'm saying this as ot dot len, ot dot width, and then om dot len, om dot width, right? Hereafter assume that this is not om or this is not ot. Hereafter assume that this is 123.len and 123.width. This is 456.len and 456.width. That's how you need to remember. No more this OT, because the OT will be only in the stack memory, not in heap memory. In heap memory we'll have only the address, right? So 456 will be here. So let me put it like this. So no OT anymore. It is 456.len, 456.width. No more OM. It is 123.len and then 123.width. That's how the memory will be pointing in heap memory. Good. And one more concept is there, right? So far, whenever we are creating anything, let me clear this up. So you remember any function or method that we create or that we used so far. Let's see, string str1 is equal to Loganathan, and then we'll say len is equal to, or to upper is equal to str upper is equal to str1 dot upper. And if I put my cursor on top of this, it takes upper and then self, right? And so far, whenever we see self, we assume that Python will take care of the self, right? We don't need to pass that as an argument. That is what we have covered in our last lesson. But now we are going to see what does the self means, right? Fine. So let me create a new Python file. I'll name it as test2. Okay. So let me create a class. I name it as, say, student this time. Student is a class. And then first I'll start with pass. Okay, then I'll explain you. Okay, now we'll have a class area. So in this class area, first what will happen? Student class will be created. Correct? Student class is created. And when I'm creating an object for the student class, what I call obj student. Obj student is equal to student of, we already know, we need to give it a student of. Correct? So what is happening when I say student of? Okay, so this is where you need to understand. Student of is nothing but constructor. Okay, what is constructor? Constructor is nothing but a function, okay, inside the class which has the same name as class name. That is what is constructor. So that's why you give the exact class name and you are putting the of, that is open brackets and close brackets, to create object for this class. So student is nothing but, it's a constructor is what you are calling. And whenever you call the constructor, what will happen? Whenever we call the constructor, it does two things. One, it calls underscore underscore new method, and underscore underscore init method. So first it calls underscore underscore new method, and then underscore underscore init method is called. Okay, so let me go back here. So the moment you create an object, so the object name, let's see, you are giving it as OS. So object student is what you are giving. The moment you create OS is equal to student of, what happens is it creates two. One is it creates new method, right? The new method, that is underscore 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 underscore. This new method is responsible for creating the object. What is meant by creating the object? Ensuring an address in heap memory. That is called new object, new method. Next is, you are going to, after this new gets called and the object is created, it is initializing it. What is initializing? So that is where you will go with underscore underscore init, right? Underscore underscore init, you go. What is initializing? It is going to create variables inside it, or functions or definitions inside it. We will come to it, we haven't covered, but for now you understand that when I create an object for a class, it is a constructor call. When the constructor call happens, it calls two methods. one is underscore underscore new underscore underscore, and then another one is underscore underscore init. What are these two methods called in Python? It is called dunder method. Dunder is nothing but double underscore. Okay, so double underscore methods. And we have special names also. This is called special method, or we have magic method. All these are nothing but dunder method. So there are many dunder methods available in Python. As of now, you remember the two, right? Underscore underscore new and underscore underscore int. Out of these underscore underscore new and underscore underscore int, I'm going to first explain the underscore underscore int. The reason is, anyways, the object is getting created. The moment I create call the constructor obj student of, the object gets created by using new. Only the init method is going to create the variables and then create an address, assigns an address, and this address gets transferred here, right? That is the job of init method. So let us use the init method then. Control E. Okay, so here now I'm going to define this init method. Even if I don't define, it is automatically defined, but right now I'm just simply putting init, and then it takes self as an argument. Make a note of it, and then I'm going to print hi, good morning. Let's see when I run this what is going to happen. You see that hi, good morning is printed. Though I have not explicitly called this init method, what happened? Just by calling the constructor, this init method is called, and whatever is inside it, it is printed. Why do we need init method? To initialize the variables. So what I do, let me initialize a variable. What I say self dot len is equal to 10. Self dot width is equal to 20. So I've created it. Now let me create one more function inside this. I'll call it as display, and here I'll say self dot print self dot len print self dot width. So what I'm going to do, I'll simply use this object to call this method inside this. So object student dot display. The dot is nothing but the accessor, right? So I'm using this object, and when I'm putting a dot here, you can see that it will already display all the possible things that I can say. So I'll use the method display. Okay, now I run this. So what it does, when the student constructor is called, it initializes the object, and within the object it puts the length as 10 and then width as 20, and then once the length and width are initialized, I am calling the method display outside the class. When I am calling the method display outside the class using the object, it prints the length and width. So what is the self then? Self is nothing but the memory. So let me explain it one more time. So first is class. What is the class? Student class. So student class has initialize, init, and then it has display, right? Two methods are there. And the moment I create an object for this OS, the moment I create an object for this, what is going to happen? It is going to create one memory, and that will be taken care by new underscore underscore new. Next underscore underscore init comes into play. Underscore underscore init, what is it going to do? It is going to first create a self dot. What is meant by self? Current object. Current object dot len. Current object dot width is equal to, it is going to assign the value. Why it is current object? Current object is going to have an address. What is the address? Say 1, 2, 3, and this address will be returned here 1, 2, 3, right? Say it is 10, it is 20. Why do we need to say self dot l, self dot width? Because this can change for every object. For example, now I've created object student, right? Now I can create one more object of new student. If I create one more, what will happen? It creates another block of memory, and inside which it says again self dot length, self dot width. So it can have 10 and 20 or another number, say 40 and 50. So these two are different, right? So when I call os dot len, it is going to print 10. If I call os object new student dot length, it is going to print 30, right? So that is why it says self. Self means instance object variable, right? It points to instance object. Let me explain this in a programmatic way. Let me, instead of saying this is student, right? So I don't go with id, I go with, sorry, length, I go with id and name. Okay, so id is say 1 and name is Loganathan. Okay, id and then name. So let me run this. So it is 1 Loganathan. But I don't want this to be hard coded. Right now it is hard coded. Instead, I want to create or assign values to my instance variables, which is object variables. What can I do? So this init can take parameters. So I say id comma name. If it is taking id comma name, then here I need to pass it. What am I going to pass? 1 comma Loganathan. So if I am passing it here, it has to get assigned id and then name. You are getting it? Now what I do, instead of student, I'll say obj student 1, and then I'll create another object named as obj student 2, and I say that id is 2. Then here I say Loganathan, and then I'll say Ram. Let me run this. Where is it going wrong? It says display obj student is not defined. Okay. Dot display. So it is printing 1 Loganathan and 2 Ram. Reason? First time when it prints for the obj student 1, it is picking the value stored in the instance object of student 1. So let me go back here. So I'll draw again. So Q. So now it has created 2. Here it has same obj os1, and then here it is os2. So os1 will have an address 1, 2, 3. os2 will have an address 4, 5, 6. So this 4, 5, 6 is given here. 1, 2, 3 is given here. And here it is self dot id is 1. Self dot id or name is equal to Loganathan. And here s dot id is 2. S dot name is equal to Ram. And that is why when we use this os2, it picks 2 and Ram. When we use os1, it picks 1 and Loganathan. What is it? Got it? And can I print it again? Yes, I can print it any number of times. So just want to show you, just because I assign a new name and new ID for, I don't want this. I do it one more time here. Just because I assign the new name and new ID, it doesn't overwrite, right? Any number of time I print, it prints 1 Loganathan, 2 Ram. So object student 1 will always have the ID 1 and Logan until I overwrite. Okay, until I overwrite, it will have that. And object 2 will always have the 2 and Ram. Okay, So we have covered what is stack memory, what is heap memory, what is class area, and also we have covered class, constructor, access operator, the dot operator, and then we have written a method right inside the class which is nothing but the display, and also we understood what is OOP and what is class and what is object. That is good. We started with the fundamental. Down the line in the next videos we will cover advanced topics of OOPs. Until next time, keep learning and keep growing. Take care. Bye.